So yesterday we saw all about functions, how functions are defined, how simple functions are defined, and we also saw how a block of expression can be passed as a parameter to the function. Then we saw parameter groups. We haven't seen any use case of parameter groups as of now because I said there is no new concept in parameter groups. It is only the syntax that is being used, and that syntax is being used in higher order functions and implicit functions. We have to still see those things. Once we see that, then the use case of parameter groups will be clear. Then we saw some variable number of arguments. Recursive functions are same as in any other function, any other language. Then we saw methods and operators. I said that there is no operators in Scala. There is only methods because Scala is a pure object-oriented program. Anything that we create in Scala is an object. And any operations we want to do on an object, it has to be through a method. Hence there are no operators, only the methods. So simple things and all we saw in the functions. Now we'll see a bit more about the functions. That is functions are called first-class citizens in Scala. I don't know why that came into picture, why they call it by that name, but we need to know the underneath uh, meaning of that. What they mean by that. So we are only concerned with the meaning. It could be anything. Jargons could be anything. So again, it goes back to Scala as a pure object-oriented program. So it is a pure object-oriented program, meaning anything that we create in Scala is an object. Even functions that we create can be internally represented as an object. A function is also internally represented using an object actually. So methods are different, functions are different. Functions are internally represented as a object here. So what I can say here is whatever we can do with objects, the same things now we can do with the functions also. So what all we can do with the objects? Let's figure out that what all we can do with the objects. We can assign a value to an object. Like we say var x is equal to 0. Assign an object to another object. So we can say val y is equal to x second. One object is being assigned to another object. So I'm trying to write this because I said now functions are also object. Internally they are represented as an object, and we also as a developers can represent a function as an object. So once a function becomes an object, what all we can do with the objects, the same things we can do with the functions also. Objects can be passed as a parameter to a method. We can objects are passed as parameters. Objects are returned from a function. So all these things we have seen. If you see, we defined a simple function, right? When we said define a simple function product, we said define product, and I said x int y int, and I said x star y. We are passing an object. When we call the function, we will pass an integer. When we call this product method, we are passing an object, and also it will return an object. It will return an object. So all these things we can do with an object. And since I said functions are also objects, we can just replace objects with the functions. We can assign a value to a function here. That is called a function object. We can assign a function object to another function object. An object, function object can be passed as a parameter to a method or a function. A function object can be returned from a method or a function. So all these things we can do here. So that's the reason they call it as a Scala as a first class citizens. Functions are first class citizens in Scala. Then we need to see what is the use case of doing such a thing. This is fine that we know what is it. We know what is it, what is a function object. It is nothing but representing a function itself as an object. Now we need to know what is the use case of all such a thing. So if you see these last 2 points, pass function as a parameter to another function, return a function from another function. So this is what we call it as higher order function. This itself is called a higher order function. Then we'll see what is the use case of higher order function. First we'll understand programmatically how we can create functions, function object, how we can create higher order functions. All these programmatically we will try to create. Once we do that, then we will go back and then we will understand the use case of higher order functions. The use case of higher order functions. Why such complex things were done, and actually it is once you get used to it, it is very simple. So with this in mind, let's say I define a function called doubler. A simple function, we know that this is how a function is written. A simple function. And I say x star. This function will just double the value of whatever we pass as a parameter. So it will double the value of 3 and give the return value of 6. Now I want to represent a function object that does the same thing. I want to create an object now, a function object that does the same thing. So how do we usually create an object? How do we usually create an object? The way we usually create an object is we say val x equal to 10. X is an object. We will say val y is equal to x. Y is an object. This is how we usually create val or var we associate with that, and we create an object. So So we can also create an object by specifying the data type explicitly here. Data type explicit. So what we'll do is we'll take this as a reference. We'll take this as a reference and we'll try to create a function object for our doubler function, which takes something. Yes, x and y represent the same memory location. Yeah, the question was whether x and y represent the same memory location. Yes, it does represent the same memory location. So how can I represent a function object or object? For that matter, we'll call it as an object. The way we create an object is in this fashion. For doubler also, I will create the in the same way. I will say val. I will say my doubler. As I said, I'm taking this as a reference. In a similar fashion, I will create my doubler. Then I have to specify the data type. Since I'm assigning x to y, since I'm assigning x to y, whatever the data type of x is, I need to specify here. I cannot say val y colon string and assign x here. This will give a compilation error. This will give an error. If I'm assigning integer, if I'm assigning integer here, I have to specify integer here. So that's clear then. So now I want to assign this function. This function I want to assign it to this object so that this object becomes a function object. So if I'm assigning that function in this fashion, I will be assigning this function. Now what should be the data type of this object? The data type of the object should be function object. I mean, we never saw that thing. Nowhere we discussed about a data type of a function. The data type of this is integer. If I say val s is equal to Scala, the data type of this is a string. Similarly, boolean, double, tuple, everything we have seen, but we haven't seen a data type of a function. So data type of a function is input data type, arrow mark again, return data type. This is the syntax. This is how we have to specify the a data type of a function. Like we have specified int here, I have to specify a data type for this function. So what is the data type? The input data type we know that is the integer. Return data type we also know that it is an integer because it takes an integer and multiplies it by 2, hence it returns an integer. So the way we write the data type is this way. So this is how I create a function object. This is how I create a function object. It takes an integer and it returns an integer. Now my doubler is an object. My doubler is an object, a function object. So I can write var my doubler here. I need to specify the data type int int is equal to, I will say, doubler. So here my doubler become a function object. Now I can assign this function object to any other object also. I can say ABC is equal to my doubler. Now ABC will also become a function object. I can assign while x, zx, y, anything is equal to ABC. Now ABC will also become a function object. XYZ, ZXY will also become a function object. Now I can call this function object. So it will multiply it by 3 and 2. So this is how we create ourselves a function object. So I hope this part was clear. Actually our goal is to understand this higher order function. Our goal is to understand this higher order function. To understand this higher order function, we have to understand function objects. Then some more 2 or 3 concepts we have to learn. After that, we have to put that together. Then you will get a bigger picture of higher order function. So probably some things may not make sense. That you can always ask the questions on that. But when we put all the things together, the whole thing makes sense. Now the first thing what we have done is we created a function object. This is a function object. I can pass it since it's an object, right? This is just an object. I can assign it to another object. I can pass it as a parameter to a function. I can return it from a function. Anything I can do with this object. So this is a function object. So we took this reference. The way we created y object, in a similar fashion we created a my doubler object. Can we create a function object by directly assigning a value? So with this reference we created in similar fashion we created. Can we create a function object in this fashion? In this fashion. So that is also we need to know here, because that is a shortcut actually. So what I'm trying to say here is, so these are called values: 0, 2.5, 10. We know that these are all called values. This is the integer value. This is also integer value. This is a double value. This is a string value. The jargons that we use is to call it as a value. Now, when I say x equal to 10, what I can say here is we are assigning a name to this value. We are giving a name to this value. Similarly, if I say x equal to 0, again we are saying we are giving a name to this 0. In a similar fashion, when I say x is equal to 2.5, I am giving a name to that value. So let's keep that in mind. Sometimes we also call it as literals. In the programming language, values are also called as literals. So we can give one more definition for literal. What I can say about a literal? Literals are values without a name. Literals are some values without a name. So literals are this, right? These are all literals. So I can say that literals are values without a name. So we can give such a definition to that. So keeping that definition in mind, what we are saying is when I say val x equal to 0, we are assigning a literal to an object. We are assigning a literal to an object. This is simple literals. Now what I said as the definition for literals, literals are values without name. Just keep this in mind. So taking this as a reference, what we can call to function literal. What we can call for function literal. Our function literals are functions. Oh, sorry, uh, not literals are values without a name. Uh, Everything changes. Literals are values without name. We gave that definition. In a similar fashion, what we can say to the function. Functions are, I mean to say, what we can call for function literals. Function literals are functions without name. Without name. So when I say def doubler takes integer and we say x star 2. When I define a function like this, what can I say about the function literal? Function literals are functions without the name. So this, if you see this is a name, this becomes our function literal. This we call as function literal. So I hope you got the difference. I mean to say I was able to give a similarity when I say val x equal to 10, when we say val x equal to 10, sorry, 10 or anything, 10 is a literal and we are assigning it to an object. We are assigning to an object. So in a similar fashion, can I create a function object? I'm assigning a literal to an object. That object becomes a simple object. If I assign a function literal to an object, that becomes again a function object. So I'm trying to showcase this. I'm trying to showcase how can I create a function object using this syntax. We saw creating an function object using this syntax. Now we'll try to create a function object with that syntax. So I will say val my doubler equal to assign the literal. What is the literal here? The literal is without a name, right? Without the name. The only syntactical change that we have to do is instead of this equal to sign, we have to have an arrow mark saying it is a. So I hope this was clear. Our goal is to create function objects so that we can later use it in a higher order function. And these two are the ways to create function object. There is one more way also to create a function object. There already exists a function. There already exists a function, and I want to create a function object for that. This is the way. This is the way. If there already exists a function, I want to create a function object. If I want to create a function object using only the literal, there does not exist any already does not exist any function here. Second. So if I want to create a product function, my product. If I want to create a my product, I can say a int, comma b as int, and I can say a star b. I don't have to define the function and then assign it to an object. I can directly create a function object in this fashion. So here is the question, let me check. A colon int will call doubler function. No, a colon int will not call. It is a function literal itself. So in this fashion, if you see, to have, there is no product method defined. So I'm just creating an object which can do a product of two integers. So this is the input and this is the definition. This is a function literal. We know that this is a function literal.
Pramod, Rajshekar.
Yes, yes, Rajshekar.
Yeah, so the def doubler equaling is a functional literal with a name, right?
Sorry, can you repeat? Your voice is a bit low.
Yeah, def doubler of equal is there, right? In the topmost line.
Rajshekar, I'm extremely sorry. I don't know. And none of the words are not getting.
Now, is audible?
Yes, now it is audible.
Yeah, fine. Def doubler in the topmost line, in the topmost line, right? The def doubler of a colon 8.
This is the definition.
Yeah, that is the definition. That is the functional literal with a name.
Right, a normal function definition. We can just say it as it has a name. Yes, we can say that.
With a name, right?
Did you ask any question now again?
Yeah, that is a name with a name, right? Definition doubler a colon int. It is a name. Functional literal with a name, right?
No, function literal is different. If you see here, this is function literal. At the bottom, if you see, function literal is the whole thing without the name.
Okay.
So just to give a understanding. So we call 10 as the literal. In programming language, we call 10 as the literal. Literal is nothing but if I take only this part, I am getting rid of the name given to 10. So as 10 is a literal, what we can say about the function literal? Function literals are functions without the name. I'll just take out this. I will take out this. So this is my function literal. So I'm assigning a literal to an object. I'm assigning a literal to an object. I can assign a function literal to an object. Function literal to an object. So using that also we can create a object. So which gives me this kind of a syntax. Which gives me this kind of a syntax. What I'm trying to do here is providing two different syntax to create an object. To create an object. So I hope Rajshekar that was clear.
Uh, Pramod, I have a question on this.
1 second. I think it is Subrat, right? Subrat, your
Yeah,
voice is very low.
yeah. Is it okay now?
Yeah, it is fine now.
Okay. Yeah, Pramod. So as you said, like we are just creating different objects, one using val and one using the def function method,
Correct.
right? Okay. Like what is the use case here? Like what is the advantage of using one over the other?
No, there is no use case. I mean to say our main goal, as I said, our use case is this. Our main goal is higher order function. And I said that initially some things may not make sense. Once we put all these things together and achieve higher order function, then everything will start making sense.
Okay, so it's like I mean, as you said, we are just creating the object using the def keyword.
Yeah, either you can do use, I mean to say a function already exists. Somebody has already returned a function and I want to get a
Yeah.
function object out of that. This is the way. This is the way. There already some function exists and I want to get a function object from that. This is the way. But I can also create a function object from scratch. No function already exists. A function does not exist at all. I'm creating a function object from scratch like this. We are just trying to create function objects, that's all.
Okay. Okay, Pramod. Thanks.
We will put into use later. We'll put these things in use later.
Yep, Pramod, why can't we just use the def function instead of using the function object?
Right, we can use the definition. We can use the definition also. But the function object use case will come into picture when we define a function higher order.
Okay,
The higher order function, when I talk about that, probably all these questions gets answered.
all right, Pramod.
I have one question like while declaring that functional literal, we didn't specify that return type, right? In the other declaration, we specified return type.
1 second.
So if you see second line, so we don't have any return type. And third line, we have a return type, right? So
Yeah, here I'm specifying, if you see I'm specific, this is the data type.
right.
Here this is not a data type. This is the function literal itself. When we have function literal itself, we don't have to, this will make sure that we'll know the return data type.
Okay.
A star 2 will, from there itself will come to know that it will have a return data type of integer. So here the reason, if you see, so if I have already defined function, I have already defined function. If I don't specify, I say my doubler here. I don't specify the data type and I use doubler here. What does this mean? Now the compiler, what it does is, it is now trying to call this function now. And whatever is returned from this function, that will be assigned to this. Compiler will treat in that fashion. Now when we are calling this function, we are not passing any parameters, it will give an error. It will think in that format. The compiler will think in that form. Now if I want to, it will treat, the compiler will treat this as a simple integer here, simple integer object, and it is trying to call this method, but we did not pass any parameters. If we pass these parameters, so now our my doubler became an integer. It is not a function object. To make the compiler understand that it is a function object, I have to specify the data type. Now it knows that my doubler is a function object. Now it knows that my doubler is a function object. Now the compiler will not call this function. Instead, it will assign that function to this object. So you can see these two differences. But when we use the function literal, we are giving this kind of a syntax itself. So now the compiler automatically understands that. So that's the way we create a function object. This is the way. This is one way to create a function object. This is one more way to create a function object. If we are having multiple parameters, we specify inside the bracket, then we specify a star b. This is also a way to create a function object. Now all these, if you see, are just function objects. Like I can say, when I say max I can say if x greater than y, return x, else return y. So as I can pass x, I can pass this object also. So we can do that, right? I mean to say, I will say val x is equal to 10. I will say val y is equal to 4. I will say something. Then I will call product method. We can pass x comma y. So x is an integer object, y is also an integer object. We had defined a product method to take two integers. Hence I can pass these objects. I can pass these objects as a parameter. Now using the same thing, we also have a function object now. We also have a function object. Let's try to compare for understanding purpose. I have val x equal to 10 and I have val y is equal to 20 and I have defined product as x int, or I will keep the name as different here, and I will say a star b. So now as I'm passing normal objects, or when I call this function, I pass x comma y. I pass x comma. So x is an object, I am passing it as a parameter. Y is an object, I am passing it as a parameter. Similarly, I also have some other object. I can pass a function object also as a parameter. I can also pass function object as also parameter. So let's say I have a function called string ops. I have a simple function called let's say it takes a string. Let's say the first parameter is a string. Now I want to pass second parameter. At that second parameter, I want to pass a function there. I don't want to pass a normal primitive data types or the normal data types. I want to pass a function. So I have to specify a function data type here. I can say yeah, and any parameter name, I want to pass a function. Now I need to say what kind of function I need to pass. Here I am saying When I say b is an int, I am saying that I want to pass an integer here. I want to pass a function. Now I need to say what kind of function I want to pass. Let's say that I want to pass a function that takes a string and returns a string. So this is how we specify. So we have to specify the data type like we specify the data type here. So this product takes two integers. This function takes one string and one function object. So I can pass a function as a parameter to this function. So I will try to write it here. So I hope I'm able to convey that. I'll just say string ops and I will say x something s. String, I will say anything, any parameter name you can do. It is just a parameter name. But I want to pass a string, or I mean to say I want to pass a function to this function which takes a string and it returns a string. And we know that this is how we specify the. This itself will make the compiler know that the second parameter has to be a function. Second parameter has to be a function. Now if I go to the diagram again, why are we passing parameters here? Why are we passing parameters here? We are passing here so that we can make use it in the body of the function. We are making use of a and b. We are using that. In a similar fashion, if we are passing a function, function has to be made use in that body. So I will just say if s is not equal to null, I will just say I will call this function. Whatever function I am passing as a parameter, that function I will call. And that function, if you see here, takes a string. Obviously I can pass yes. Yes is a string here. S is a string. S is a string. Else I will just return yes. So this is called a higher order function. So this is called a higher order function. So this is why we define a function object so that we can pass an object as a parameter to another function. So when I call this function, how can I call this function? I will call first parameter should be Scala, second parameter should be some function. Second parameter should be some function. And how that function should be? It should take an string and it should return a string. That function should take a string and return a string. Let's define a function convert to upper, I will say. Let it take a string. To remove the confusion, I will just say something else. And it returns a to uppercase. There is a method on the string called to uppercase. It will convert into an uppercase and it will return. You can see that. If you see this convert to uppercase is a function that takes a string and it returns a string. Obviously I can pass this function as a parameter to this function. String ops. The first parameter is a string. Obviously I have to pass a string. Second parameter, it expects a function object. So I will be calling this function. So it is just like assigning doubler to my doubler. If you go back here, it is just like this. It is assigning a value to a my doubler. My doubler data type was this, but here n data type is it takes a string and returns a string. So now n is nothing but s is nothing but Scala, n is nothing but convert to upper function. So now here we are calling that convert to upper function, which will take Scala as a string and it will return the uppercase of that function. So this itself we call as a higher order function. This itself we call as a higher order function. So next, there is something we need to still know. Then we will understand the again we'll see the use case why we need a higher order function. Just before that, there is one shortcut. Yeah, here is a question. Can we pass multiple input parameters and return? Right, we can do that, Rashid. We will see an example on that as well. We'll see one example on that as well. So now there is one more thing we have to know. We know that we need not define this function. So that's what we did tell here, right? We need not have a definition like this. We need not have a definition like this. We can directly have a function literal. We can directly have a function literal. I don't have to define the function, then pass it as a parameter. I can directly use the function literal here. What does the function literal is? Only change I have to make is instead of equal to sign, I have to say. So we know that this is a function literal, right? I can do this. It will give me the same result. So that's the reason I was talking about the function literals. Sometimes you will see the code in this fashion also. If you have come across Python lambda expression, this itself they call as a Python lambda expression. So this is how and there is one more shortcut they use. There is one more shortcut they use. The shortcut is there is no logical way of explaining this. As I explained all these things in a logical way, the shortcut I cannot explain in a logical way because there doesn't exist in any logical way of explaining. So like I can say val, I can define a function object my product which takes x int y int and it just says x star y, x star y. So this is a function literal. We know that this is a function literal that does a multiplication of two integers. That function literal I have directly assigned to an object. Now this object is a function object we know now. On top of this, what they have done is they have replaced the input parameters need not also be specified. Input parameters need not be specified, but we need to specify the data type so that the compiler understands. So the compiler understands that it is a function object which takes an integer and it takes two integers and returns a integer. So now the one shortcut they are achieving here is they need not specify the parameter names. They can just use underscore. So first underscore meaning the first parameter. Second underscore meaning the second parameter. So we can use just the underscore as a placeholder for the input parameters. Underscore can be used as a placeholder for input parameters. So it will give us the same thing. So when I call this function, and pass 4, 5, 4 is first underscore, 5 is second underscore. It will be in that order. It will be in that order. It will be in that order. So this you have to remember this. You cannot put any logic on top of that to understand this. Intuitively you have to remember this, and as you write and keep on writing programs in Scala, it will automatically be in your mind. The only thing is it requires a bit practice, that's all. But this these underscore only work if there is no repetition. If there is no repetition of the parameters in the body, it only works in that case. The shortcut is not very generic. Your function body has to be a single expression. The one thing is the function body has to be a single expression, and also there should not be any repetition. Meaning if I have val square, I want to compute a square. I want to create a function object for my square. How do I do? I will just say my square or square equal to, I take x here as an int, then I say x star x, and I say x star x. So this creates a function object. This creates a function object which gives us the square. I can just give square of 5. It should give me 25. Now I cannot use underscore here. Now I cannot use underscore here. So if I say it takes a int and it returns a int, and if I say underscore, star underscore, so it will not work because the compiler thinks that first underscore is the first parameter, second underscore is the second parameter, but we are only passing one parameter. So this is wrong. It says that wrong number of parameters expected. So underscore will not work if you have a repetition, and underscore will not work if we have a block of expression as your function object. Your function has multiple expression in the body. Even in that case, it is not. It has to be using the parameter name itself. So if I consider this, in our string ops, the very first thing what we did is we created this function and passed as a parameter to the function. Then what we did is we use a function literal. We used function literal and we said s dot to directly you use the to uppercase. No need to define a function. Now I said that the input parameter can be replaced by an underscore. We need not require this. This is a shortcut. So I can remove everything. And I can just say underscore here. Underscore means the input parameter to the function that is being passed here. This is a function we are calling, and we are passing a function. And this underscore is a input parameter of that function. is the input, is a placeholder for the input parameter of that function. So this is how we, so if you see, there is one more underscore we used. As I said earlier also, underscore is extensively used in Scala, and based on in which context it is being used, the definition of underscore differs. We saw a tuple is being accessed using an underscore. Then we saw default case in a match expression is the underscore. Here we are seeing underscore as a placeholder for the input parameters of a higher order function. So if you have worked with Java, in Java we know that we use the import statement. When we use import, we use, if you want to import all the classes of a package, we say dot star. Here we say dot underscore. Here we say something as a dot underscore. I'm not sure whether somewhere. So I can just use in this fashion. Dot underscore. Yes, Rajshekar, it is being recorded. It is being recorded. So dot underscore. So as I said, based on different, based on the in which context you use an underscore, the definition of or the meaning of the underscore differs. So this is our higher order function. So now question comes, why are we doing all such things? Why can't we write a simple function and achieve the things? Why we have to do all these complex things to just achieve the same things? We can do it using the normal functions also. Why did we go for a function object? Why did we go for a function literal? Why are we using a higher order function where we can pass one more function as a parameter to that function? So now what is the use case of that? What is the use case?
Pramod, here I have a question.
Yes, Rajshekar.
Can you come back, to this, like Scala cell?
Okay.
Yeah, you know, right, Scala, you are talking a string of, right, you know, first parameter as input parameter to uppercase,
So, sorry, Rajshekar. I don't know whether it's my volume or 1 second.
yeah, my question is,
Yeah, can you repeat the question once again?
you are calling string of, right, the bottom line.
Okay.
Scala, you are passing input parameter, but the underscore dot to uppercase. So
Correct.
your first parameter has input parameter to the two uppercase.
So this underscore is yes here.
That is the input.
Correct. That
That
is
is the
input parameter to the function of this function. Whatever function we are passing, that's the input parameter to that function.
yeah. My question is Scala you are passing to that uppercase, right?
Correct. That itself is being taken as the input parameter.
If you make it a Scala 1 means it will again Scala 1 will print.
Right, right. This itself we are passing as an input. But that is not mandatory. We need not pass that itself as a to uppercase may fail here.
Yeah,
I don't
correct, correct. Yeah, yeah. That is Scala's.
In this function we have defined in that fashion. We have passing, if you see, this is the definition. If you see, the definition of our higher order function is we are passing the first parameter itself as the to the to,
Oh,
the, to our function, whatever we are passing as a parameter. But we can pass any string here, not necessary that it has to be this string. The only requirement is it has to take a string. The only requirement is it has to take a string and it has to return a string. Not necessary that this string itself has to be passed. I can hard code some string here also. I can
I got
pass
it.
any string. Yeah.
Pramod, one more question here.
Yes.
In the Scala, right, we are passing the parameter as a value or by reference.
It's a reference. I mean, it's always a
Okay,
copy
copy. Okay,
because it's immutable. We cannot change it at all.
okay.
So keeping that in mind, our main question comes into picture here. Why higher order function? Why higher order function is required? So let's say I have a array. Let's say I have an array and I have like I have some string, an array of string. Now what I will do is I may ask you to write a function such that it sorts the array. Write a program. Write a program to sort the array in, let's say, ascending order, ascending or descending order. Write a program to sort. Obviously we can write a program. Then what we'll do is we'll ask write a program to sort by second character. Again in ascending or descending order. Obviously we can write one more program here which sorts it by the second character like L, E, E and R. In a similar fashion, I can ask you to write a program to sort by last character. Again in ascending and descending order. In a similar fashion, I can say write a program to sort by length of the string. Length of the string in again descending, ascending and descending order. So obviously we can also write a program. Length of this is 3, this is 4, this is 6, this is 5. So red should come first, blue should come second, green and then yellow. So we can write a program for this also. But what we have to do is we have to write the program for every problem statement. We have to write the program for every problem statement. What if we could write only one program? What if we could write only one function and pass the logic as a parameter to that function and pass the logic as a parameter to that function? So that's the use case of the higher order function. This is one of the use case. That's one of the use case of the higher order function. you reduce the number of lines of code drastically here. So instead of writing lot of code, we reduce it here. Instead of writing more and more code, we reduce it into a simple thing and expose a simple API to the developers. So most of the time, we ourselves may not write our higher order function. There are a lot of higher order functions available in Scala. There are a lot of higher order functions available in Spark also. So most of the time we use the higher order function, because if you want to write a higher order functions, first you have to come up with lot of problem statements. Yes, this function can solve this problem, that problem, another problem. Only then we can make it as a generalized function. So most of the time we write our own, we don't write our own. Most of the time we use the higher order function. So instead of writing lot of functions, we achieve it with the less lines of code. Lesser the lines of code, lesser the bugs. Lesser the bugs we can have, lesser the maintenance, lesser the resources are required. So here I can just say reverse. I need not define a function like convert to upper. I need not define a function like convert to upper and then pass it as a parameter. I can directly pass that logic here itself. I can directly pass the logic here. Whatever we pass as an input string, that string is reversed and it is sent. So that's the idea. So that's the idea of a higher order function. We reduce the number of lines of code and achieve lot. With few lines of code, we achieve lot of things. That's the use case. That is one of the use case of higher order function. Going forward, we will learn one more use case. One more use case of the higher order function, which is more related to parallelism. We'll see that as well. But I hope till here things were clear. So I assume the things were clear here. Next what we'll do is we will try to write more and more higher order such functions. So I can define a function, let's say simple ops. I will say simple ops, which takes two integers and it also takes a function and that takes two integers and it returns an integer. So let me define a function here. Let me define the body of this higher order function. I can define val m is equal to x plus 2 something. Val n is equal to y plus 2. Then I can say val p is equal to I will call the function here. Whatever function I pass as a parameter, that function I will be calling here. You can call it anywhere. The only requirement is it has to take two integers. We know that m is an integer and n is also an integer. I'll pass m and as a parameter. And now, since this function returns an integer, p is also an integer. I can do something with p star 2 and then. So you can call that function anywhere. You can call that function anywhere in the body, and whatever it returns, anything can be done with that return value also, and we can return this. So this clearly says that simple ops is a higher order function that takes three parameters. Out of that, first two parameters are integers. The third parameter is a function. It expects a function to be passed as a parameter. And what type of function I want to pass? I can pass a function which takes two integers and it should return an integer. Let's say I define sum as a function, and let's say it takes two integers, and let's say it does a plus b. Obviously you can see here that sum is a function that takes two integers and it returns an integer which matches this data type. The only criteria is to match the data type. Only the matching function can be passed as a parameter, not everything we can pass. As simple as you cannot pass a string here. You cannot pass a string here because it expects an integer to be passed. In a similar fashion, we cannot pass any other function other than which takes two integers and returns an integer. So obviously I can pass a sum here. I will do simple ops. I will pass 4, 5 and I will pass the sum. So when I call this function, this should get evaluated. Now x is 5, x is 4, y is 5, f is nothing but our sum function. 4 plus 2 is 6, 5 plus 2 is 7, 6 and 7, 6 and 7 are being passed to the sum function. To the sum function, 6 and 7 are being passed. So it will just add 6 and 7, which will give you 13. P will be 13 here. Just multiplying by 2, 26 we have to get it. So this is how we can achieve a higher order function with multiple input parameters. I hope, Rajshekhar, this was your question. Right, next we will see that. I said that we need not define this function. We don't have to define this function at all. We can directly use the literal of the function. We have already seen that what is the literal of the function. This is our literal of the function. I can directly use this. Only thing is equal to sign has to be replaced with the arrow mark. And we have also seen the shortcut. That parameters need not be specified. We can just use a placeholder in this fashion. So this is a function. This is a function literal which takes two parameters and adds those two parameters. So we can have a shortcut in this fashion. Yes, Rajshekhar.
My question is like in Java right now, we are not directly defining our method and we are calling directly. Not passing the argument like a placeholder in the function.
One second, Rajshekhar, your voice is again lost. Or 1 second. Even I am experiencing a degraded audio quality from my side. Just a second.
Okay. Can you audible now?
Yeah, it is audible now.
Yeah. My question is like instead of passing the function as a parameter to the any function, so instead of calling inside the function, can we call that function directly from the function?
This function.
Yeah, instead of passing it to that, you can call directly in the F in the top one, right? So instead of f, we can call them sum directly. We cannot do that, right?
We can call that. We can call that.
Uh,
That is also possible because it's a simple function.
so instead of passing it, you can directly call there.
We can directly call that. Then you cannot call any other function. I mean to say I can call that function here, somewhere
Yes.
here. Meaning I already have a function, right? So I can define my simple ops. I can define my simple ops. It's just like any Java or anything.
Yes.
Again, I can say val abc is equal to sum. Now you are hard coding it with the sum. Now you are hard coding the your code with the sum. If I have in this fashion, but I'm not making use of these things anywhere. So if you can call it here also, but here it become what it becomes here is it becomes only sum can be evaluated here. If I want subtraction also to be done, if I want subtraction also to be done, so again I have to write one more function which takes the subtraction. If I want product to be done now, if I want product to be done, I have to write one more function where I write product, call the product. I have to define product method also, then I have to call that product method. So now instead of
But
that, yes, Rashikar.
yeah, as you said that simple apps make it more generic you're talking about, right?
Yes, yes.
But how it will detect that, right? How that will detect whether this is a subtraction or multiplication or addition, right?
No, the logic, we give the logic.
Okay, okay, okay,
We
okay, fine, fine, yeah,
we have to give the logic as a parameter.
fine.
So I will redefine this function as it was earlier, the simple ops. I will redefine it as it is. Then I said that we can have, I will call this simple ops. I will say 4 comma 5 and I said I can say underscore plus. Now if I want to do the product, I can just say product here. It will just do as if we are passing the product function now. As if we are passing the product function. If we want to do subtraction, we have to just do subtraction. We have to just do subtraction. So we don't have to write the function again and again with different method being called. So we are making it a more generic function. So here, keeping this in mind, what will be the result for this? So we know that there is no operators. This is a plus method inside the, uh, it is a plus method. This is a star method. This is a minus method defined inside the class of an integer. And what is this here? That is also a method, but what will be the result of this? What will be the result? Any guess here? Anybody can try it out? Yeah, if you see the answer lies in your answer itself, it returns a boolean, right? But what we have defined our function expectation. Any function that you pass that should take two integers and it must return an integer. And it must return an integer. But we are not returning an integer here. We are returning a boolean. So if you pass for y, if you pass true, can we pass true to this to this here? In a similar fashion, we cannot expect a boolean when we are when we want it to be a integer. So it will not work. It will not work here. Type mismatch. It says found boolean. The required was integer. This greater than always returns a boolean. So we cannot pass that function. Such function we cannot pass. We can only pass a function that takes two integers and it must return an integer. That kind of functions only we can pass. So we cannot pass any other function. I hope that was clear. I hope that was clear. So now how can I make it work these things also? So this is a higher order function. We usually don't write such kind of a higher order function. As I said earlier also, these kind of a function will already exist in your Scala program, Scala library. As well as in Spark, such kind of a higher order function already exists. We have to just use those things. And such functions are made more generic. It should not fail in such a case. It should not fail in such a case that it only takes a integer or a double or a such kind of a things and does not work with a boolean. Now how can we make such a function more generic? How can we make such a function more generic? So that it can take different type parameters, different parameters. So obviously we can use the type parameters. We can use the type parameters. If you remember, I said about the type parameters where type can also be passed as a input parameter. So if you remember the identity, if you remember identity where I said type as T and I said S is of type T and I just return this and I just return S. So now I can call this function. Now I can call this function with Scala. Now I can call this function with 10. Now I can call this function with true, anything I can. So I can combine this type parameters with the higher order functions and make it more generic. Already it is a generic function. By combining with the type parameters, we are making it more and more generic. So I will define the string ops once again, but in a simple fashion. Simple ops, I will say, it takes two different types of parameter. So when we want two different types of parameter to be passed, I specify two different types, comma separated within the square bracket. So and I will say x is of type A, y is of type A, and it takes a function. The third parameter is a function which takes type A, and it returns a type B here so that I can change what is the return data type. So this becomes more generic function. What I will do is I will not write much things here. I will just call this function. I will just call this function with x comma y. If you see that x is of type A, y is also of type A, and the function also takes two parameters of type A. Obviously, I can call that function with x and y. So now this becomes more simpler. I mean to say more generic. So I can call simple ops. First parameter I will say 2, second parameter 3, anything 4, then I can say underscore plus underscore. I can say underscore plus underscore. Addition works. My mistake. One second. Type also I'm being passing as a parameter. A is of type integer. A I'm saying as an integer. B is also I'm saying as an integer. Hence it was able to do this plus. Unless it knows that it is an integer, it cannot call this plus method. It cannot call this plus method. So this integer works for star also. It works for minus also. So now if I want to make it as a, I want to check whether 2 is greater than 4, this I have to make it as boolean. This I have to make it as a boolean. The return type B is boolean. B as made as boolean. So this function will look like, now this function will look like A is an integer, X is of type int, Y is of type int, F takes parameters of integer and it returns a boolean. So obviously now this will also work. So this is how we make our function more and more general. So it says that 2 is not greater than 4. 2 is not greater than 4. So in a similar fashion, what will be the division here? If I specify int and int, obviously the decimal point, integer divided by integer will give you a truncated integer. The decimal point will be truncated. So it is better to make it as a double. Just make it as a double. Even I think double, we have to just make it. Any one we can make it as. Let's see what is the 0 point. It will not work. So any one, so if I make both as double, so it gives a correct result. So this is how we make your function more and more general. So I hope the things were clear here on how to use a higher order functions. The only thing is, going forward we will be using lot of higher order functions. We will not, there is already defined higher order functions. We will be making use of that higher order functions. We will be making use of that higher order. So keeping that in mind, there is one thing remaining on higher order function. So the function in most of the cases, the function that we pass, if you see the function that we passed as a parameter, were simple functions like addition, subtraction, in this fashion. Is it? Yeah. If you see this function, it has only one expression. This function has only one expression. We are passing only such kind of an expression. We are passing such kind of a function which has only one expression. Let's say our function has a block of expression. In that case, we cannot use the underscore. So let's say our, I have, I'll just say new sum which takes x int y as int. So instead of doing just a plus b, I will have a val a is equal to x plus 1, val b is equal to y plus 2. Then I will just say a. So I can pass this function. I can pass this function because it takes two integers and it returns an integer. Obviously I have to make it as int and int. Then I pass all the, I will say 4 comma 5 and I will say new sum. So that should give me the result. That should give me the result. But now here I cannot use underscores. Here I cannot use underscores, but I can use the function literal. We know that this is the function literal. This is our function literal. I can use this. I can use this. I'll just remove this slashes. These are created by the compiler or the shell. These pipes will come from the shell. And only change I have to make is this. Only change, instead of equal to sign, I have to make arrow mark. So I can pass, this is our function literal. What this function literal defines, it takes two integers, it does some addition and all, and finally returns an integer. This is our function. I can pass this as my input parameter. I can pass this as an input. You will see such type of a code also being returned. You will see such type of a code also being returned. So what it means is, it takes two integer, and this is our function literal that is being passed as a parameter. This will be called inside our simple ops. That function will be called in our simple ops, which is this. That function will be, I think this is the one, right? Whichever, I mean, I change it later. Yeah, it will be just called. That function literal will be called. F will be that function object, and we are calling this function. If I run this program, we should get the same result. So here we cannot use a underscore. Here we cannot. Whenever there is a block of expression that you are passing as a parameter, that's where you cannot use an underscore. Also, when there is a repetition of the same parameter again, we cannot use the underscore, because the compiler doesn't understand which parameter to use in that case. So I hope till here higher order functions were clear. So all these examples you can see in this document as well. So we can have any number of parameters. If you see, they have one triple operation also, which takes three different parameters, and a function which takes three parameters and returns a function. So we can have all these combinations in this fashion. Triple operation. Type parameters also is given here. So all these things are available. So I hope higher order functions was clear. It takes a bit of a practice. I know it is a bit complex, but once you get used to it, as I said, you don't have to define your own higher order function. Most of the time we make use of that, and as you keep writing some or the other programs, you'll get used to that. This is how we use a higher order function. So now there is one more concept with the higher order function, or not one more concept actually. There is one more way to create a higher order function. So we used these two syntax. Already defined function is there, and from that function we get a function object. This is one way of creating a function object. One more way of creating a function object, you just use the literal of the function. There is one more way we can get a higher order function, is through partially applied function. So what do we mean by partially applied function? So the name itself says a partially applied function. So meaning, let's say I define a function called factor. Let's say I define a function called factor, x as int, y as int. Then I will check. The factor is nothing but I want to check whether x is a factor of y. X is a factor of y. Whether x divides y. Like 2 is a factor of 4, 2 is a factor of 6 because 2 divides 4 and 6. 3 is a factor of 15, 3 is a factor of 9, 3 is a factor of 21 because 3 divides 9, 15, 21. So I just want to check that. So let's define a function. Let's define a function. So I can get a, what do I mean by partially applied function is, the name itself says it's partial. I mean, when we call this function, we don't pass all the parameters. We hold back certain parameters. We partially pass few parameters. We don't pass all the parameters. We are partial here. We are being partial here. We only pass few parameters. We hold back certain parameters. So I will just say 5. It has a bit of weird syntax. Here we use again a placeholder underscore, and I will say integer. Here what we mean by this syntax here is, I am passing the first parameter and I am not passing the second parameter. So this is how you don't pass the second parameter. So this is why we call it as a partially applied. I am applying only partial parameters, not all the parameters. When we do such a thing, it returns a function object. It returns a function object, and that function object will take the remaining parameter. It will take as a input the remaining parameter. So if you see here, this factor, it did not get called. What happened instead? Instead it returned a function object which takes an integer. This integer is the remaining integer. It is the remaining integer. And since it returns a boolean, the function object will also return a boolean. So now there are use case. I have one use case which is based on Spark. Wherever you might have heard about user-defined functions in Hive, or in Pig you might have heard. In a similar fashion, Spark SQL also has user-defined functions. So this partially applied functions use case we can see there. But also we can show some simple use case. We know that this function returns a function object when partially applied. So I can just say, instead of this, I can store it in some object called isEven. So now isEven is a function object. IsEven is a function which takes an integer and returns a boolean. Instead of when I do isEven, I will pass the first parameter as 2. Let's take the first parameter as 2. So I can call this function isEven, and I can say 4 here. 4 is that second parameter. First parameter is already 2. We will divide 4 by 2, and it should give a result. Whether we use this function as a factor function to check whether x is a factor of 4, x is a factor of y. In this case, it will be whether 2 is a factor of 4. That factor function we are using, and we created a new function. We created a new function with the already existing function. We didn't use the same existing function. Instead, we can say that From an existing function, we create a new function. That's what is used as a partially applied function. The real use case I will just show when we learn Spark SQL. So obviously, if you see, easy1 is more readable now, but we are internally it is nothing but is using the factor. I can say whether 5 is even, it will say false. I can create one more function, is divisible by 3. Some object like this, I can call the factor, I can 3 underscore star int. So is divisible by 3 is also a function object to which I can pass 5, so it says false. 5 is not divisible by 3. We will say 6 will be divisible by 3, hence returns true. 21 also it returns true. So we can create different functions from an existing functions. That is a kind of a use case of a partially applied function. But here if you see, they say partially applied functions and currying. Oh, I forgot to say, parameter group itself is called currying. Grouping parameters itself is called currying. So we have seen parameter grouping. I can rewrite this factor function once again. This we know that this is a parameter group. This itself is called as currying. There is one more name for parameter group which is called as currying. I think I did not say that, but yes, it is called as currying. With currying, the syntax becomes a bit simple. With currying, the partially applied function syntax becomes a bit easy. So I can say val is even is equal to, I can say factor, I will pass to the whole parameter group, I can represent it by a underscore. So if you see here also underscore is being used, but it has altogether a different meaning. It means that we are not passing that second parameter group. We are holding back the second parameter group. We are only passing the first parameter group. So this why the syntax becomes more, it's the same thing. Whatever we saw earlier example, it's the same example, but with the parameter group, or we can say with query. Obviously it will return true, for 4 it will return true, for 5 it will return false. So that's what we call as a partially applied function. Partially applied. Yeah, we have seen invoking higher order function with function literals, blocks. Block of expression we saw. This also we have seen. So next collection, I think this we can start from the next session. Again, we can, I hope this whole session, the whole 2-hour session, almost 2-hour session was all about higher order functions. So our to give a understanding why we learned the higher order function, to give an understanding. So first we learned function, then we learned higher order function. Going forward, we will learn collections like list, map, hash map, sets, vectors, all those things we'll learn. Next we'll see how higher order functions are applied on collections. This is important. This is important. Applying higher order functions on collection. That's the one more use case that I will be discussing, use case of higher order function. The one more, I said that there is two use case of higher order function. One is to drastically reduce the number of lines of code and achieve lot of things with a few lines of code. We still need to see one more use case which is more to deal with the parallelism. That we will be discussing here. And it is also important, the same thing applies for Spark also. The same thing applies for Spark as well. So these things we will be seeing. So I hope today's session was useful. So let's wind up the session here and let's continue tomorrow. I hope all the three videos are available. I hope did I hope did I send the link to everybody? I hope everybody is able to view these videos.